Welcome to the first notes of the geometry class online. You'll notice the next unit we're talking about is solids, so we're going to look at 3D shapes. The essential question is, what is a polyhedron and what are its important features? So we're looking at what a polyhedron is and things about it. Again, we'll take these notes on here. I would recommend taking the notes on a piece of paper or in your notebook again. And I would upload them to your Google Drive folder that we made yesterday. That way you can have access to your notes online if you need them at any point. So the key terms, we're going to look at a couple things first. We're going to start off with what a polyhedron is. So a polyhedron is a solid 3D shape that is bound by sides that are polygons. That is bounded by sides that are polygons. That's kind of the key part there. If we think about polygons from before, we talked about this before, a polygon has straight sides. They're closed, that kind of thing. So it can't be any circular things. So it has to be polygon, so it has to have straight sides, and it has to be closed. So some examples of a polyhedron. We'll different color for this one. Let's go with blue. So an example, and bear with me, my drawings might not always be the best, but if I did a prism, so you can have rectangular prisms, triangular prisms. I'll just draw a rectangular one here, so I kind of draw a sideways rectangle, and each side is going to go up. So that would be a polyhedron. It's three-dimensional, and each of the sides are polygons, because each of the sides are rectangles. Another one that's pretty common is a pyramid. So in a pyramid, you can have a triangular pyramid, a square pyramid. What that means is what the bottom shape is. So if I said a square pyramid, the bottom would be a square. I'm going to draw it tilted a little bit. And then for a pyramid, instead of going up and meeting at another square, like the prism does, it goes up and meets at a given point. So if I met here at this point, each of the corners would go up to this point here, and you'd have a pyramid. So it has less faces, but each of the faces is a polygon. The bottom's a square or a rectangle, and each of the sides are triangles. That would be an example of a polyhedron. Non-examples, this in red here, so ones that do not work, that are pretty common. First one is a sphere. So, or like a globe, which is like a circle, like this. So it's a 3D, like the world, kind of a globe idea. That is not a polyhedron because it is round, curved, no polygon sides. Also a cylinder, because again, the top and the bottom are both circles. Circle on top, circle on the bottom. If you connect that, that would make a cylinder, but again, the top and the bottom are not polygons. And then a cone will also not be a polyhedron because the bottom, again, is a circle, which is not a polygon. Okay, so those are some examples of shapes that would not be polygons. These are the main 3D shapes we're going to be looking at this unit. So prisms, pyramids, spheres, cylinders, cones. And the polyhedrons are the prisms and the pyramids, which is what we're looking at today. When we're looking at these shapes, there's a couple things that happen. There's three things we're looking at. The first is a face. The second is the edges. And the third is the vertices. So these make pretty common sense in terms of just logic, thinking what they are. The face is the polygons, or the sides of the figure. So it's the polygons, or the sides of the figure. Okay, the edges are the line segments of where the polygons meet. So if you're looking back here at this prism, this would be the edge. So it is a line segment where the faces meet. And then the vertice is the points or corners where 3 or more edges meet. So it's the points, also known as the corners, where 3 or more edges meet. Okay, so the first kind of assignments you're going to have with this are going to give you a picture of a particular shape. So let's look, and we'll do a different color, mix it up, we'll go some purple here. So if I do an example on this, let's say I drew a, let's do a rectangular or square pyramid. Say that's right here. So all those points go up. I guess I wouldn't see that one be dotted. Okay, so if I drew that, okay, as best I can. So I had that shape. The question would ask you how many faces, how many vertices, and how many edges it has. So number of faces, number of edges, and the number of vertices. Okay, so I did this math. So faces might be the easiest one to start with. So if I look at the faces, that is all the flat surfaces, the polygons. So I know it has 1 on the bottom, this bottom section here. So underneath that bottom part there, and then I know it has a side here. 1, 2. It has the 3rd one in the back, and this 4th on the side. So I know this would have 5 faces. The edges is the line segments. So again, if I'm looking at edges, I kind of trace them here. 1, 2, 3, 4 on the bottom, and then 5, 6, 7, and then 8. That back one there, so it has 8 edges. Vertices is the corners where they meet. So it'd be 1 here, 2, 3, 4, and 5. Okay, so that's kind of a way to think about it. You're going to be counting on different shapes. Some of the shapes are harder than others. Just take your time and look at each individual part. There is a cool theorem that somebody came up with, Euler actually came up with. It's called Euler, looks like Euler, but Euler's theorem. So he did a lot of counting, counted the vertices, counted the faces, counted the edges, exactly what we just did. And he noticed that there is a pattern every time. And it's actually the number of faces plus the number of vertices equals the number of edges plus 2. So if I did the one I just did, it'd be faces plus vertices, there was 5 vertices, equals edges, which was 8 plus 2. So there's 10 on this side, 10 on this side, which means I counted correctly. Sometimes it's easy to miscount, and this is a good way to check. So Euler's theorem will allow you to check. This is kind of the formula. There'll be a couple problems in the book that ask you to use the formula to check your work. You just plug them in and see if you actually counted correctly. So after Euler's theorem, we're going to look at 3 different types of polyhedrons. There's a regular polyhedron, a convex polyhedron, and a concave polyhedron. And you should recognize these names, regular, convex, and concave. So a regular is kind of like a regular polygon where all the sides are the same. It's basically exactly like that, except we're looking at a 3D shape, which means all of the faces are the same. If all the faces are the same, that means all the faces are congruent. So all the faces are congruent, regular, which means all angles and all sides are the same, polygons. So the main shape, really the only one we're going to look at much with this, is a cube. Because in a cube, each of these sides are exactly the same squares. So the bottom is the same square, the sides are the same square, the length, width, and height of the entire thing is exactly the same. So for convex and concave, remember these, concave is where the shape caves in, convex is where it does not cave in. So when you're looking at 3D shapes, the way we define this is if you have 2 points on the surface, in a convex polyhedron, they are connected by a line through the figure. And for a concave, same idea, but 2 points are connected by a line, that's a bad line, outside the figure. So if we look at this figure I drew here, I try to make it kind of like a book. So if I take a point on one of the sides over here, so let's take this random point here, and let's put some other point on the bottom on this side. If I connect those two, so you can pick any points in the entire figure, if I connect those two, would that line be outside or inside the figure? Through the figure, it would go outside. So in this particular one, if I think about it in 3D, from the top left to the bottom right, that would go outside the figure, which means this shape is concave. If you think about like a rectangular prism, for example, all these go back. That works too. So if I drew this shape, that's a really bad rectangular prism. But if I had this, if you connect any points from here to here, it would always go through the figure, which means that shape would be convex. So concave caves in. You can also pretty much tell by looking at the picture if it caves in or not caves in. But the actual definition is the line goes outside for concave, inside for convex. The last thing that's on your homework and look at is called a cross section. And how that works is they're going to take any shape. So I try to draw a cylinder here, and you cut it basically at any point. So I'm going to cut it, I don't know, either direction. I'm going to cut it this way. I'm not very good at drawing these, so I'll do the best I can. So if I drew like a shape, basically like a plane that went straight through this figure. So it hits there, goes through it. What shape would you see in the middle when this plane kind of hits it? So you'd see this shape here. Basically what it would make a circle in the middle. Correct? Then you have the outside space. Would go through it, but it would make this circle if you cut it down the middle. Okay, hopefully you can imagine that. Just like if you cut a hexagonal pyramid or prism, you would see a hexagon. If you cut a rectangular one, you'd see a rectangle, that kind of idea. So the cross sections ask you, if you cut it, basically, what shape would you see right here? And you would see a circle. That cross section you see is a circle. So those aren't too bad, just sometimes the wording can be a little bit confusing on what you see in the middle of that shape. Okay, that's basically it. You'll see the link to another note kind of thing online, so if you want to check that out, it has the same kind of idea as this. There should be a picture of the bookwork as well. If you have questions, let me know. Again, I would save these notes to your Google Drive along with the assignment, and then submit the assignment on Google Classroom so I can give you credit for doing the solids work. It is due on Friday, so you have a couple days to work on it. And the assignment is, again, page 798 and 799, numbers 15 through 31. So the goal of today was to watch the video and get an idea how to do it. If you want to start the assignment, you're welcome to. Tomorrow's goal is to actually do the assignment and turn it in. Please let me know if you have any questions, or you can sign up for appointments so we can meet at that point if you need help.